Hello, we're doing the second part of checkpoint 4.33. The first part asked us to find a function that the amount of time that it's going to take for this person to run along the shore, stop at a certain point, and then swim to an island that's 1 mile away from the shore. And we came up with this time formula. So this is the amount of time that this person is going to take depending on where x is along the shore. Now, what we want to do is we want to minimize the time, and our x values go between 0 and 15 here. And so let's work on that. To do this, we're going to take the derivative. So we have t prime of x is going to be just the 1/6 plus 1.25, or 1 divided by 1 divided by 2.5. And the derivative of this is going to be something to the 1/2 power, so I would say 1/2 1 plus 15 minus x quantity squared to the negative 1/2 power, and times the derivative of the inside. The derivative of 1 is 0. A derivative of this is going to be 2 times 15 minus x. And then now we want to take the derivative of the inside again, so that's going to be just negative 1. All right, using a big, long chain rule, this is what we end up with. And we're going to set this equal to 0, but first we can try to simplify. It looks like we can cancel out a 2 and distribute this negative 1, so I have x minus 15. Although it might be okay to keep that negative 1 there anyways, because as I set this equal to 0, it'll come up with a negative. So let's keep the negative 1 out. We're going to set this equal to 0. 0 is going to be equal to 1/6 plus 1 over 2.5, and this would be negative 1, 15 minus x divided by the square root of 1 plus 15 minus x quantity squared, all under, it's all under square root. Now when we set this equal to 0, we'll bring the 1/6 over to the other side, and we'll start with that. So that negative 1 and that negative sign can cancel itself out. And everything else will stay the same. And let's actually see it cancel so that we don't have to worry about that negative sign. And I think I'd be interested in bringing this 2.5 up on top, and this one also on the other side. So we would multiply both sides by 2.5 times the square root of this. So this will give me a 2.5 divided by 6 as a constant. And then we have the square root of 1 plus 15 minus x quantity squared equal to 15 minus x. I got this to be, let's see, if we multiply this by 10, this will be 25 over 60, and then we'll divide out by 5. We're going to get 5. 5 into 60 is 12, so this is going to be 5/12. 5 over 12. All right, now that we have slightly nicer numbers to deal with, we will square both sides. So square both sides, we're going to get 25 over 144, and this whole thing without the square root. And then we'll square this side, so this is going to be foiling it out. So 15 and 15 is 225. The middle term would be negative 30x, and then plus x squared. All right. It looks like we will have that here as well. Actually, instead of foiling it out like I just did, why don't we keep it as 15 minus x quantity squared, because I'm seeing this here and we might be able to take advantage of that. So let's distribute the 25 over 144. And this is a bunch of algebra that you just have to be careful, and there's many ways to approach this in solving for this equation, and I'm just choosing certain ways to try to make it easier. But if you feel more comfortable about doing it a different way, then by all means feel free to do it that way. Okay, now I have this. I'm gonna subtract this from both sides. So I'm going to need to have 144 divided by 144, which is essentially 1 minus this. So I need to figure out what 144 minus 25 is. And this is going to be 9. This is this is 3. And this is going to be 1. So 119 over 144. So this is 25 over 144 is equal to, bringing this whole thing over to the other side will give me 119 over 144, and then 15 minus x quantity squared. I can multiply both sides by 144. That will get rid of that. And I can divide both sides by 1 over 19. So this is 25 divided by 119 is equal to 15 minus x squared. We'll take the square root, so there's going to be a plus and minus. Let's continue on over here. So the square root of that, and I'll have 15 minus x is equal to plus and minus the square root of 25 over 119. And then I can solve for x. So I'll subtract the 15 and I'll divide by a negative number, which will still be plus and minus. So this will be positive 15 plus or minus the square root of 25 over 119. Okay, so given that your domain needs to go between 0 and 15, means that if you have 15 here and you add something to it, then it's going to be bigger than that. So your actual answer must be 15 minus that square root value. So this would be x equals 15 minus the square root of 25 over 119. And I think that was approximately 14.54. So you basically run almost the whole way, leave about half a mile, a little bit more than half a mile, and then you start swimming across. So this is a distance that you would run along the shore, about 14.54 miles. And then you stop and then you swim the rest of the way to the island. All right, I think that's it. Technically, you should check to make sure that this is in fact the minimum. Let's just say that it is, and if you were graphing it, you should be able to see, if you graph the original function, you should be able to see the dip down minimum, and then the x value would be this. And then if you want to figure out the actual time that it takes, then you would take this number and put it into the original time function, and then it's gonna tell you how long it's gonna take. All right, I hope that helps.